Hey guys, we're going to review for the test, so let's do it. The overall essential question says, how are sides, segments, and angles all related? So this chapter, we see that if I have a triangle, right, with the sides small, medium, and large, then the angle opposite would be the largest angle, and the medium angle, and the smallest angle. So it's pretty prevalent in this chapter that we see large sides are opposite large angles. That would be one way to say, how are they related? How are the sides and angles related? And when we think about segments, we can think about sides, but we can also think about how we can cut things in half, right? So if I think about a triangle and I take my sides, right, pick a side and cut those in half. If I cut them in half at a 90-degree angle, that's a perpendicular bisector, and it leaves me with two equal segments on each side. And so we notice that there's a lot of things going on with sides and segments inside triangles, and we use these relationships to create or find centers. All right, so that's what this whole chapter is about. So let's investigate. So as a memory tool, I said, all my children always bring in peanut butter cookies. All right, this helps me remember. I could use my notes though too, of course. That altitudes, this one, altitudes make circumcenters. So these go together. And what else? Well, we know angle bisectors. Again, I'm using those letters as a guide. Angle bisectors make incenters. Right? And what else? We know perpendicular bisectors perpendicular bisectors make circumcenters. So I have forgotten this. That's why I have a memory tool, circumcenters. So yeah, altitudes. Oh, I got my memory tool wrong. Okay, so let's take this back a minute. Okay. It's all of my children. Yeah. Okay. So that helps me remember all of altitudes make orthocenters. So if I have trouble remembering these, and I've taught it for 6 or 7 years, you can see why this little memory tool helps me out. Orthocenters. Now, you would, for the test, not have to memorize them because you have your notes, but for the midterm and the final, we won't have our notes, right? So we do have to kind of know these and figure out a way to remember them. So what is MC? Well, that's in medians make centroids. Okay, so now using this information, let's see if I can connect these and fix my mistake here. Okay, yeah. Altitudes make orthocenters. Altitudes make orthocenters. Medians make centroids. Okay. And perpendicular bisectors make circumcenters. Angle bisectors make incenters. So they don't really talk about this, but those are made by perpendicular bisectors. And these are made by angle bisectors. Okay. Concurrent means 3 or more lines meeting in a single point. Equidistant means the same distance from each other. Right? Equidistant. And that's basically it. Okay, so let's connect these to these. It says the blank is the point of concurrency of the angle bisectors. Okay, so AB, angle bisectors make incenters. Nice. And 3 or more lines that connect. Okay, that's our concurrent. Those are called concurrent. When 3 or more lines meet. All right, the point of concurrency of the altitude. So we said altitudes make orthocenters. All right, a perpendicular segment from a vertex to a line containing the opposite vertex. That sounds like the altitude. So it's a perpendicular from the vertex that makes a 90-degree angle, makes a 90-degree segment. Okay, so that's our segment. That's definitely our altitude. And it says nothing in here about cutting it in half. That's why it's not a perpendicular bisector. A point that's the same distance from other points. That's this word equidistant. Okay, and then a blank of a triangle has endpoints at a vertex and at the midpoint. Okay, that's the definition of our median, right? So if we had a triangle and we find the middle and we trace it back to the opposite vertex. Yep, so from the middle to the opposite vertex. From the middle to the opposite vertex, middle to the opposite vertex. Those are all medians. Cool. All right, so now let's take a look at 5.1. It says perpendicular bisectors and angle bisectors are related. Any point on the perpendicular bisector is equidistant, right? Because when we cut something in half, we cut it in 2 equal pieces, right? So perpendicular bisectors is this line right there. What did it do? It cut this line in half. That means that this is 10 and this is 10 because 10 is equal to 10. This whole line, 20, was cut in 2 equal pieces. So what else do we know? Well, we know that this triangle should be equal to this triangle because of this shared side here. So the top triangle, ABD, is congruent to the bottom triangle, CBD. Why? Because it looks like side, angle, side. So because of side, angle, side, those are twin triangles, which means this second side should match this second side, and so that would have to be 36. Now, you don't have to know all the reasons, but that might come up on the midterm, right? So we're just kind of reviewing there. So let's dive in here. It says, using this picture, let's say PS is 36, okay? PQ is 3x plus 5, okay? QR is 6x minus 10, all right? RS is 36. Oh, okay, so these are equal. Well, that's interesting because these are equal, and that's 90 and that's 90. So this triangle and this triangle are congruent because of HL. The hypotenuses are both 36, and they both share another leg, so they're equal. Now, what does that tell us? Well, that tells us we can set these guys equal to each other, right? That means this second side would match this second side. I guess I'd call that a third side, right? So these are equal. So probably on a piece of notebook paper, you'd want to do this. So I'm just going to add 3x plus 5. 3x plus 5. I mean, you might be able to fit it on there, but I can't. All right, 3x plus 5, 6x minus 10. 6x minus 10. All right. Getting close here, right? Getting close to my answer. So it looks like x is 5. All right. So if x is 5, what is the length of each side? This was one side, and that was the other. So if that's 5, I get 20. And if that's 5, 6 times x, well, x is 5, I get 20. And yep, 20 is 20. So let's see what they need. The question says, find PR. Well, we solved this is 20 and that is 20. So PR would be 40. 40 was cut in half. It was 20 and 20. Nice. So it says, using the same picture, so I'm going to erase this stuff. You would write it on another piece of paper, hopefully. Okay. And I'm going to insert this same thing. So PS is 4x plus 8. PQ, 29. RS, 5x minus 3. QR, 29. Oh, well, that's cool. They share this side. This is 29. That's 29. So that means that this triangle is congruent to that triangle because of side, angle, side. They both have a side, an angle, and a side that match. So that means we could say that these third sides match, and I can put that on my notebook paper. 4x plus 8, 4x plus 8 has to equal 5x minus 3. Okay, so let's figure out what x is. All right, I'm gonna so that would just be x is 11. So if we plug this in and we plug that in, what do we get? So we got 4 times 11 plus 8. 44 plus 8 is 52. Then we got 5 times 11 minus 3. 55 minus 3 is 52. So yes, 52 is equal to 52. So let's take a look. What are they looking for? What is PS? So this is 52. That's 52. So I'm just going to write 52. Next one. New picture. It says JM is 12, LM is 12. Okay, that's nice. They share this side. And they have an angle that's in common, right? And so it looks like these are the hypotenuses that match, and these are a leg that match. So this triangle on the left is congruent to this triangle on the right, which means the other sides have to be correspondingly congruent. So now what they're saying is if this angle, JMK, this angle right here, if this is 25, then that means this is 25 because that's its twin angle. Those are twin triangles. So what would KML be? It would also be 25. You could also think of it, this whole angle would be 50 degrees. The 50-degree angle was cut in half, and that's why it's 25 and 25. All right, next, I got to use the same picture. So hopefully you're doing this on notebook paper. Don't erase, I want to see your work. But okay, so new question. JML is 49. So if the whole angle here is 49 degrees, then I think I know where they're going with this. This is going to be half and half. So that would be 24 and a half degrees if I cut it in half. So, oh yeah, and they confirmed that this one is 24 and a half. And so this one also has to be 24 and a half because 24 and a half plus 24 and a half is 49 degrees. So let's see if those would be twin triangles. This triangle has an angle and a side. All right, here's an angle, here's a matching angle, here's a matching side. Here's an angle, here's another matching angle, here's a matching side. So because of angle, angle, side, those are twins, which means this side would have to match that side. And that's what we're looking for. They're saying this is 17, so we know this has to be 17. That's our answer. Okay, one more to review, 5.1. Reason, a point on a perpendicular bisector. Okay, so let's draw a picture. Let's cut this in half, add a 90. Okay, so this is my perpendicular bisector. So they're saying some point along in here. I don't know where. Some point on a perpendicular bisector is 7 centimeters from each endpoint of the bisected segment. So this is the segment that I bisected. And they're saying that this point, where whether it's above or below, I don't think it would matter. This is 7 centimeters and that's 7 centimeters. Okay, it said it's also 5 centimeters from the point of intersection. Okay, so this is where this point and the two lines intersect there. So they're saying this is 5 centimeters. Okay. To the nearest tenth, what is the length of this whole segment? Okay, so what is the length of the whole thing? Well, I see a right angle. I hope you do too, right? So I can use Pythagorean Theorem here to solve for the missing side. I'll call this A. So A squared plus B squared is C squared. It appears one of the sides we don't know. One of the sides is 5, right? So we'll square it. One of the sides is, the hypotenuse is 7, so we'll square it. So we get A squared is, what is that, 20? All right, so but we don't want to know what A is. We want to know what A squared is. We want to know what A is. So A has to be the square root of 20, and it says round to the nearest tenth. So let's see. Looking at a calculator, we're going to pull up a calculator. Oh, no. I don't have a calculator laying around. Hold on one second. Let me get that. Online calculator. All right, so the square root of 20 is 4.47. Okay, so this is 4.47, and this is also 4.17. So the whole thing is just 4.47, times 2. All right, so rounded to the nearest tenth, the length of the whole segment is equal to 8.9. Nice. Okay, so that's our vocab, and those are our questions for 5-1. Let's look at 5-2. So it says bisectors in triangles. Okay, so perpendicular bisectors make circumcenters. That's peanut butter cookies. Angle bisectors make incenters, always bring in. All right, so what are we supposed to notice? Well, if something's inscribed, then that means the circle fit inside. That's the center. So what do we observe? This distance, and this distance are all radii. So that's why they set those equal to one another and they solved. They're solving for the radii. Nice. Okay, and that happens with incenters. So let's look here. It says, identify these points of concurrency. Well, we know that incenters always fit inside. And so this point A, it has to be a circumcenter because it's outside, right? We also know it is formed by perpendicular bisectors, right? Here's the center of the side, and they made a perpendicular line at that midpoint. So those are made by perpendicular bisectors, and so point A would be the circumcenter because it's made by perpendicular bisectors. All right, what about our incenter? Well, incenters are made by angle bisectors. So see, it looks like if this was triangle ABC, angle A was cut in half, B and C were cut in half. So point K would be an incenter because it's made by angle bisectors. Nice. So what happens with 15? It says GFL is 34. Okay, so let's zoom in, and that means, right? That means that would be 34, and that would be 34. So the whole thing is 68. 68 was cut in half, 34 and 34. What is GEL? GEL is 36. Okay. So that means this is 36 and this is 36. So that means the whole thing had to be 72. All right, so can we find this last missing angle? Well, sure. We know that 180, take away this angle, and take away that angle, find out what's left over, 40. So this angle has to be 40. So let's see what they're looking for. What is FGL? FGL. Okay, well, if it's 40, then 40 can be cut in half. The whole angle is 40. So if they just want FGL half of it, then we can say FGL is 20 degrees. All right. If JL is 5, okay, so if JL is 5, what is this? 5, right? Because a circle fits inside, and they are radii. So KL is 5 because they are both radii, and radii are equal, the plural of radiuses. 17, the circumcenter of a triangle, so that would be this would be an example of that. The circle triangle is on one of the sides, okay? And so that happened to us when we had a right triangle. So let's just remember, if we cut all the sides in half, and then we make a perpendicular line, when we cut those in half, notice the intersection of all those points lands on the triangle, not inside. So the circumstance of a triangle is on the side of the triangle. Explain how to find the area of the circumscribed circle of the triangle given the lengths of the side. Okay, so what would be the circle, the area of the circle? Well, the area of a circle is pi r squared. So what's r? Well, this would be r, right? That would be r. So how would I figure this out? It looks like r, and you'd be right, that circumcenter, the circumcenter is half of the hypotenuse. Okay, so if the circumcenter is half the hypotenuse, then if I know the length of the side, the radius is equal to 1/2 the hypotenuse. So how would I find the area? It's equal to pi times 1/2 the hypotenuse squared. Awesome. Check out the next video for the last 3 sections.